What's up, math scholars and math haters? This is Mr. W. We're going to tackle question 6 from the 4th grade math questions that North Carolina released this past school year. We're being asked to tell which list contains exactly 2 prime numbers and 2 composite numbers. Really simple question, just one idea that they're going to try to make a little more complicated, but we're awesome, so we're going to handle it. All right. So prime versus composite. Any prime number is a number that is going to just have itself and 1 as factors, as smaller numbers that you can multiply in order to get this number. Composite numbers are the opposite. A composite number is going to have at least one other factor besides itself and 1. So as an example, I'll go over choice A. The number 13, this one's actually going to be prime. Number 13 doesn't have any smaller numbers that you can multiply by each other or by something else to get 13. But 14, however, I'll just write a quick factor pair above each one that's composite. 14 you can get from 2 times 7. Since 14 is 2 times 7, we call it composite. In a similar way for 15, 15 is 5 times 3, so we would call that composite. And then 16, we can do a few different things, but I'll do 2 times 8 to represent 16. Now, these are just different pairs of factors, and they don't necessarily have to be prime numbers themselves. There are examples of what's called prime factorization, where you break a number down into all its prime factors, trying to get even smaller than, for instance, 8. I could break that down a little bit more. But anyway, we're not worried about that right now. Choice B, if I've got the number 2, 2's prime, 5 is prime, 4 I can write as 2 times 2, and 6 I can write as 2 times 3. So it looks like in this list we have 2 prime numbers and 2 composite numbers. So I'm going to put a dot next to that because I'm thinking it's going to be right, but I still want to check the others and make sure. For choice C, 7 is prime, 8 we can say is 2 times 4, 9 we can say is 3 times 3, and 10 we can say is 2 times 5. 3 of these are composite, just the 1 is prime, so that one won't work. Let me go ahead and cross these out as we eliminate them. And then for choice D, now that I have a little more room, I'll use it. 25 is 5 times 5. 26 is 2 times 13. 27 is 9 times 3. And then 29 is going to be my only prime number in that list. So D is out. So in choice A, choice C, and choice D, we had just 1 prime number, and the rest were composite. But choice B then is the only one left where we have 2 prime numbers, 2 and 5, and then the other 2 are composite numbers. 4 is 2 times 2, and 6 is 2 times 3.